So tell me, what is a neural network? A neural network is a computational model inspired by the human brain. It is the same answer. Okay, the consisting of the interconnected nodes we call neurons that process information through weighted connections. Okay, it is type of machine learning algorithm that learn to prefer tasks by analyzing examples. So neural networks are widely used for the various applications like image processing, natural language processing, we can call it NLP, and predictive modeling. Okay, so when it comes to the key components of the neural network, there are four main parts. Okay, first one is neurons or nodes and connection, weights and layers and training. When we come to the neurons, there are basic units of neural network. So similar to nervous cells in the brain, each nervous receive input and process it and pass the output to the next layer. Okay, first one is each neuron receives some inputs and process it and pass the output for the next layer. And we come to the connection part or weight. So neurons are interconnected with the weighted associated with each connection representing the strength of connections. Okay, and another thing is layers. There are three main layers. Neurons are typically organized into layers in input layers, hidden layers, and output layers. This one is the input layer, and this one is the output. Hidden layer, and this one is the output layer. So in the input layer, takes the raw data. For the example, we can say physical value for an image. We can get the physical values for the images, and in the hidden layers, perform computational and extract features. In here, perform the computations and extract features, and finally in the output layer, produce the final results. It is a classic. It can be maybe a classification label. Okay, when we come into the training, neural network learn to adjusting weighting through procedure called backpropagation. So using the algorithm like gradient descent of the minimize the error between predicted and actual output. Okay, so let's see, move on to the how neural network is work. So we can say like this, when we get the input, we can feed the data is feed into the input layer, the first layer, and we want to process it. The neuron in the hidden layers process into the input, and the output it passed to the next layer. So in the output layers proceed the final result, such as prediction or classification. When you come to the learning part, the weights of the connections are adjusted during the training and improve the network performance. Okay, so in the neural network, there are many types of neural networks. Okay, these are some examples for the neural network. In the mainly we are using convolutional neural network, recurrent neural network, and NLP. So convolutional neural network specialized for the image and video analysis. Okay, when you come to the recurrent neural network, it is good for processing sequential data like text and speech. And it also another type. It is a NLP, natural language processing. We are using for that for the sentiment analysis, for the predictions. Okay, so do you have any idea about the applications of the neural networks? Applications. We are talking we are creating some neural network. So what are the applications of the neural networks? In the real environment, we are using neural networks. So okay, the applications of the neural network, we can say like this. Some application for the image recognition and processing. For the example, facial recognition in the smartphone and security. We are using that for the smartphones and security system. Okay, and we can say another thing is object detection for the self-driving cars, and also another neural network is a NLP. The application of the NLP are language translation, or we can get Google translation or sentiment analysis. We can classify the reviews as positive or negative. Okay, and also we can get chatbot and virtual assistants for the NLP, for the application of the NLP, natural language processing. Okay, so finally, what are the challenges in neural networks when we are creating or after creating the model? So when we are creating a neural network model, need a larger amount of data. So neural network performs best when training a larger data set. So in many cases, collecting and labeling enough quality data difficulty and expensive. So we want to create a neural network. We want to collect some more data. We want to collect some larger data set. Okay, to train the model. So to effectively train a neural network model, you cannot use only few number of input samples. A larger dataset decides the dataset is required to ensure accurate learning and generalization. Okay, so before feeding the dataset into a neural network, you need to check the pre-propagation, creating the parameters such as missing value, normalizations, and data quality. Okay, you want to consider those parameters. Okay, so you will be able to understand those theories and concept during the lab practical sessions. We will doing this lab practical using Google Colab. It is a free cloud-based platform provided by Google, and that allows users to write to execute Python code and directly in the web browser. So let's get started. The first step is you want to search in the Google Colab in your browser and click on the appropriate result. So you want to search as Google Colab. So you can see welcome to the Colab, and this is the link for the Google Colab, and you can click it. It is redirect to the Google Colab. So you can see this type of interface. So if you want to open a new file as a notebook, go to here and click it and new notebook in Drive. Click it. So it is redirect and open the new notebook. Okay. After when we are using the Google Colab, especially it's made for the machine learning and data science, and do some practical lab. For Google Colab is a free access to GPU and TPU. The Google Colab provides the free access to powerful hardware accelerators like GPU and TPU, which significantly speed up training and learning models. So we want to know installing required. So runs internally in the browser. So you don't need to install Python or any libraries or Jupyter Notebook on your computers. So it is a pre-installed library. So comes with many popular libraries like NumPy, Pandas, Matplotlib, and also another thing is the TensorFlow, and these are all pre-installed in the Google Colab. So we can save the time and effect. So cloud storage are integrating. So integrators with the Google Drives, so you can save and open and share your notebooks easily from the Google Cloud. So it is another thing is it is good for the beginners. So it is the user-friendly interface and great for the students, educators, and anyone learning the Python or machine learning. So you can follow with me. So firstly, you go to your browser and search Google Colab and click the appropriate results. In here, you can change the name. So if you want to change the notebook name, you can do like this. But you don't edit the file extension. It is IPYNB. You can only edit this one. Okay. So firstly, you need to import some necessary libraries to require to train in the model. So it is a Python based. No, so if you want to put some comments, you can input with the hash. So in here we are importing packages for model. Okay, so in here firstly we want to import packages for the model. So in here firstly I code it and after I explain. So in here we want to import TensorFlow for as tf. Okay, and you want to press shift and enter, and it is get some couple of minutes and import package for the Google cluster. So in here this is the line imports the TensorFlow libraries. Okay, which one of the most popular tool used for the machine learning and deep learning. And the TensorFlow is a package. The TF in here we use TF. The TF is a short name used refer to the TensorFlow in your code. Okay, and after use TensorFlow to build, train and run the neural network and other machine learning models. If you after coding you want to press the shift plus enter, it will take some few minutes and import the libraries. Okay, did you all done that? Firstly you want to go to the search browser and type it Google Colab and select the appropriate result and go to the file and open a new notebook and rename, or it is okay if you rename with the extension so ps1.ipynd. So after firstly you want to import the package for the model. We are creating some model, neural network model. So we want to import the TensorFlow as tf. So after we want to import some required libraries. So in here we want to these are the required libraries: NumPy, Pandas, Seaborn and Matplotlib. So in here firstly I write the code, then after I describe first import NumPy as NP. Okay, and also we want to import Pandas as DD. Okay, and another library is import Seaborn as SNS, and another thing is import Matplotlib. We can suggest some keywords, so you can click it. Finally present it with the in line. Okay, so after you can enter shift and enter, and after the libraries are imported for our model. So in here we import the NumPy. It is a library. This library used for working with the arrays or numbers or mathematical functions in this library. Okay, so in here we use as NP. Why we use NP? NP is the short keyword used for your code. Okay, and after we import another library as Panda. The import Panda library for handling for the data tables called data frame to help with the reading or writing or analyzing structured data. And also we import some Seaborn as SNS. It is another library. The import Seaborn, it's a library used for creating a graphical representation or informative chart working well with the pandas data. Okay, and also we are using import some library matplotlib. It is a basic charting library for line chart or bar chart or scatter point or PLT. In here we use PLT. PLT is the some common keyword for the matplotlib. So in here we use %d with the inline. So this is the Jupyter Notebook command. It is make charts show up inside of the notebook right after the call cell runs. Okay, did you all import the packages and the libraries?
Yes, sir.
Okay, so after we importing the libraries and packages, we want to import some layers to our network. Okay, so in here we are using TensorFlow with the Keras. We want to import some layers, dataset or model. So we can simply type like this from TensorFlow.Keras import layers and put some comma and data set and put some comma and type it models. Okay, and press enter. So you want to import some another layer from TensorFlow .keras device import category. This one and enter. So in here we import some layers. So you are importing the main building blocks of the Keras, which is high-level API in TensorFlow used to build and train the deep learning model easily. So what is the layer? Layers, the model of the provide the various type of layers, like example for that dense layer, contour and flatten. Used to build the neural network architecture. We are using layers for the building the neural network architecture. So in here we some code data set, the sample data set we can use for the learning and experimentation, and we are getting some model content tools for the defining some managing neural network models, and also we type some to categorical, the utility of the function of the convert the class the label. For example, we can get 0, 1, 2 into 1 for encoding vectors, and we can also use neural networks work better with the one-hot encoding output for the classifications problem. Okay, these are the import packages, libraries and layers if we need it. So okay guys, I will share with you the data set. Okay, this is the data set. There are 5 columns and 150 or 51. Let me see. 150. Yes, 150 rows, and there are 5 columns of the data set. The data set contained with the .csv file extension. Okay, the CSV file contains the famous iris flower dataset with the following details. In the dataset, there are 5 main columns. First one is sepal length, all are plots and integers numbers. Okay, so sepal length contains the length of the sepal in centimeter. So sepal width of the sepal in CA, and also petal length length of the petal in cm and petal width of the petal of the cm. And final column, the class, the species of the iris flower. It is example for that iris setosa, iris versicola, and iris virginica. There are 150 samples rows in total. Okay, there are 5 main columns and there are 150 rows are including in this data set. For each rows representing one iris flower measurement with the corresponding species. Okay, and when it comes to the input or features, the first 4 columns, this one, and this one, and this one, A to D, special length, width, petal length, width, are numerical features representing the measurable properties of the flowers. These will be input variable to the neural network. These are the input data for the neural network, the column A, column B, column C, and column D. When we comes to label or output, the last column, this one is the class. This is the categorical label indicating the flower species. This is the target variable of the neural network will learn to the classify. Okay, the final goal is, in this practical session, the final goal is the neural network will be learned to classify the flower species based on the 4 numerical measurements based on these 4 columns. Okay, this is the classic multiplication classification problem with the 3 possible classes or species. In here, another thing is you want to know supervised learning and unsupervised learning. Did you hear about any these 2 words, supervised learning and unsupervised learning? The supervised learning is a type of machine learning where the model is trained using the label data. Okay, we have some data, but we are labeling those data. This means we already know the correct answer or output for each example in the training dataset. Okay, we know the dataset and we know the exact output. We are labeled. Okay, example for it is classification flowers, like in the iris dataset. This is the model learned from flower measurements and their known species. We know that each row corresponding to one flower. So we know the swell length, sepal width, petal length, and petal width, and we know the output, the correct exact output. So how this works? So you give the model input features, get some example for like petal length. So and you also provide the correct output for the flower type. Okay, and the model learn the relationship between the input and output you enter. So it can then predict the output for new unseen data. Okay, the supervised learning is a type of machine learning where the model is trained using the label data. This is the mean of we already know the correct answer for the output for each examples in the training dataset. So then what is the unsupervised learning? So is when the model is given data without the label. So there are outputs, but we are not labeling those. So the goal is to discover the pattern or group in the data. So giving some example for the unsupervised learning, get some customer segmentation. So grouping similar to customer based on the buying behavior without knowing their category beforehand. Okay, so tell me, in this practical session we are using flower iris. So tell me, it is a supervised learning or unsupervised learning? What is your answer? Someone asking, what is the learning? What is the method? Okay. So tell me, what is the reason why you think it is
know the output
as a
Yeah.
class?
Yeah. it is as an output, and we are label those output. So we are know the output of each result. So for that reason, we are using supervised learning for the creating this model. Okay, and the file format is .csv, and now you want to import the CSV file for the notebook. So go to the collapse, and in here you can see some icon of the file, and you want to click it, and it has some uploaded image. Okay, icon of the upload. So click on it and select the correct .csv file format and replace for the our model. Did you got that method? Go to the file icon and click on the upload icon and give the correct path for the .csv file and continue. Okay, so now you can import the dataset for the your network or model. So in here I will put some message comment importing dataset. Okay, in here you want to get the variable name as a data equal, we are using panda, so we can use the keyword as pd read csv and open brackets and with the current, and go to the your file path. You can select the three dots and click it and copy the path. Okay, copy the path and replace this path to here. First one is you want to get the variable name as data equal to pd read underscore with the csv, and you want to replace the correct path and press the shift and enter. So the dataset correctly imported for the our model. If you get some error, it is mean of the file is not uploaded correctly for the your model. Okay, so in here we are using pd. What is the pd? Pd is the nickname for the pandas library, which is I already told, which is commonly used for the data analysis and manipulation in Python. So in here we use read underscore csv is a function of the panda that read the .csv file, and it load your data into a structured table called data frame, which looks like an Excel sheet and in Python. Okay, and another thing is this is the file path. This one is the file path to your data set, and it tells Python where to find the .csv file. Did you understood? This is the file path to your data set. It is tell Python where to find the .csv file, and this is the data. This is the variable that stored your loaded data set. Okay, so after you can represent in your data set. So in here after loading the data, become a data frame that you can explore or filter and pass into the machine learning model. In here you can simply type data and enter, shift and enter. Okay, then it is representing your data. It is same like your Excel sheets. In here sepal length, sepal width, petal length, petal width and class. So in here we can represent in the model in the sepal length, sepal width, petal length and petal width with the class. In here only shows the first 5 rows and last 5 rows in here. Okay, so in a Google Colab, okay, after we can I want to know how many times each flower species class appears in our dataset. So it's quick way to check the distribution of the layers or category. We can simply do like this: data, open square brackets and open double quoted and put the class. Why I use class in here? Is there any answer? In here I use class. What the reason for that? In here we know the last column name is class. Okay, that's the reason I use class in here. And dot, you want to get the value counts and open the brackets and shift enter. In here show some results. Okay, in here related this one, I want to get the count of the results. So in here I got the data as the variable and put the last column name and value count. In here, according to that, the column contains the species name of the each iris flower. In here you can see first few are iris setosa, last few are iris virginica. So this function count how many times each ununique value appears in the column. Okay, it is return a list showing each flower species and the number of times it is occurs in the dataset. So we can say like this: there are 50 number of data related to the I-series setosa, and another 50 count of numbers of the data related to the versicola, and another 50 data set related for the iris virginica. All count is 150. Okay, so after I want to create a scatter plot of the sepal when versus to the sepal width. So each of following is our data set with different colors for our flower species, and it is help to visualize how the flower species are distributed based on the two features. How can we do that? In here previously I told SNS or seaborn represent the graphically charts. So in here we are using seaborn's function. Type like this SNS and mention some keywords and you can click it. So open bracket and the variable name is data and put some comma, UE equal to double quoted, the column name is class, and put some space and enter. So you want to map this, so dot map and open the bracket, ELT keyword and splatter, put some brackets. In here we are getting the sepal length versus sepal width. In here you want to replace this column name, sepal length, in here, and it is versus to which one? Sepal width. Okay, it is versus to sepal length versus to sepal width. Okay, enter, and you want to add underscore length. Bracket and shift enter. Keywords error. This is the reason. You want to use so in here we want to use seaborn. So simply SNS dot and open the brackets, and you want to name the data, and the comma equal with the double curly. You want to put the column name, enter, and you want to dot map the keyword flat dot in here you want to input the sepal length, the column name, and you want to input the second column name as sepal width. Okay. We want to add shift enter. Yes, it is now correct. So in here you can represent in the some colors in the dots. So in here we are using SNS best grid. So in here SNS refers to the seaborn, the Python library used to make in the get some beautiful and graphical representation. So easy to understand this chart. That's the reason we are using seaborn. The keyword is SNS. It is created grid layout for the plotting. So in here we are using HUN equal to the class. Mean plotting will be colored based on the flower species. Mean in here the three type of flowers, no? So variation of the flowers. It's a setosa, the virginica and versicola. In here we can see the iris setosa representing with the blue color, the versicola representing the orange color, and virginica representing in the green color. So in here we use map. So this is the map of the scatter plot of the function PLT scatter to the data. So it is used x-axis. You know, this is the x-axis representing the sepal length, and this is the y-axis using for the sepal width, and each point in the scatter plot representing the one flower. These are the plots. So these are the representing one flower. So tell me, how many plots are there?
150.
150. That's the answer. So representing the one flower, no? So there are 150 plots. So in here, after that, we can add some legend. At the legend, you can which color representing the which flower species. So now you want to do is we want to divide the data set into two parts. We have 150 data set. So I want to divide into two main parts. So first I code it and explain. So in here we are getting some variable as x and equal it to data ilog. Ilog, open the square bracket and double dots, comma mark with 0 and 4. Okay, and you want to get the value. Values, and you want to do as the getting the y equal to data dot data clock. Open the square brackets. Hit the comma and input 4 and values. Shift enter. So in here we have done the main reason for. So tell me if you have no any answer for the why we divide into two parts. Previously I told I want to divide that data set, the 150 data set rows, no? So I want to divide that data into two parts. The main reason for the dividing the data set is that during the model training we need to separate the input data from the output data. And typically when you training a model, we use x to represent the input feature and y representing the target output. Therefore I will follow some same approach. So this line I will discuss in here. In the finally we split the data into 0.2 for one for the training data set and one for the testing dataset. Okay, in here I use data.ilog. In ilog used for the select the data by position, row and column index in here. So double dot means select the all rows. In here I put the double dot in representing the select the all rows. In here 0 to 4. What the mean of? With the mean of select the column 0 to 3rd, which are sepal length, sepal width, petal length and petal width. So this the give you the input features the measurement of the flowers. And dot value, this one is a dot value. Dot value convert the data frame slice into numpy array, which are the formatting most machine learning model are required. So in here we are use X features, stories, input measurement, shape 100 rows to 4 columns. There are 150 rows and 4 columns. And Y label 150 and is there 1 column. Reason for that, the output label as the 1 column as class. Okay, so just think I want to print the few row of our input feature data X. Especially it is shows rows 1 to 3rd. That means index 1 to 3 and from the X array. So I can do like this: print open brackets which array I want, X. So the array name, variable name is X, and open the bracket 1 to 4. So shift enter. It is representing the data of the 1 to 4. It is representing 4.9, 3.0, 1.4. These. Okay. So tell me, if I want to print with the 0 column, what is the value we want to insert? In here I insert 1 to 4. In here representing 4.9, 3.0, 1.4 and 0.2. If I want to get the 5.1, 3.5, 1.4 and 0.2. What is the index we want to insert in here?
Zero.
That is the correct. In here replace with the 0 and shift enter. It is representing the 0 row. Okay. Each row representing the one flower. So in this row representing the one flower according to the sepal length, sepal width, petal length and petal width and the output label. Okay, and each column representing the measurement of the sepal, those parameters, and we can do same like for the y axis. Print open bracket, the variable name is capital Y, and open square bracket 1 to 4. This one is the output of this result. In here 1 to 4 means it is represent the first row. So it is iris setosa, no? So it is representing the iris setosa. So next I want to print the shapes, size or diamonds. So in our data set, input are as X and labeled as Y for the data set. So this is the useful for checking whether the data structures correctly before training a machine learning model. So in here we can insert print, the variable name is X dot shape, and we want to print the variable name is Y dot shape. So in here representing 150 rows with the 4 columns. It is representing this 150 rows and 4 columns for the inputs. And in here for the y-axis representing 150 and last column as class. So in here output 150 and 4, there are 150 flower sample and 4 features for each sepal length, sepal width and petal length and petal width. in here output representing the 150 with the comma. So 150 label, one for each flower sample. So this help, we can get some help verify our data before feeding to the machine learning model, and the output, input and output should have matching the same count. That is the reason we are checking with the shape. So now we are considering, after done those things, we want to do some pre-processing. Okay, we got some idea about the inserting packages, libraries, and layers, and input the CSV file, and also we got the count and we plot the chart, and we get the check-in and confirm the input are all are in the correct format and correct count. And in here, after doing those things, we want to pre-processing those data. So do you have any idea about the pre-processing part? Pre-processing. Do you have any idea about pre-processing? Speakers, pre-processing means simply like this, cleaning and preparing our data set. No, say like this. Pre-processing means cleaning and preparing our data so that it's a machine learning model can learn from accurately and efficiently. And also pre-processing. So tell me, can we discuss why pre-processing is very important for creating a neural network model? So the importance of the pre-processing is machine learning models work best with the clean, structured and numerical data. So raw data, we are using in here raw data. So raw data may have missing value. Sometimes in the Excel sheet some missing value. In here all are filled, but sometimes there are some missing values in the .csv file. So raw data have some missing value, text labels or different scales, which one can confuse the model. So just think, if you not fill those blanks or columns or rows, so model can confuse. So you want to pre-process and put some average, or you can put some zeros, wait for those columns. So and help the models to learn fast and more accurately, the pre-processing part. So finally, the common pre-processing steps are, the first one we can say data cleaning, remove or fill in missing incorrect data. Just think some values are missing in the .csv format. So we can remove. We can, first thing is we can remove those that row, or we can fill the missing value with the correct data. Okay, and feature selection. So just think, pick only important column and feature for the training. We can get ignore those rows and we can get the important columns, and we can ready for that for the training. So another thing is label encoding. To convert the text label like iris setosa into numbers the model understand. Okay, so another thing is normalization or scaling. Make sure all numerical values are on a similar scale. We can say like 0 to 1. And training test slip. In here, divide data into training and testing part. In here we can get 80% for the training and we can get 20% for the test. And final thing is one host encoding convert the categorical label into the binary vector used for the classification. Okay, in the machine learning, especially we working with the neural networks. So it's important to convert the categorical data to the numerical format that the model can understand. So process is called encoding. So for example, in our data set, our data set is flower iris. So in the last column representing the flower species, so which are categorical labels like iris setosa, iris versicolor, and iris virginica. So neural networks and other machine learning require these labels to be in a numerical format. These are text. So neural networks and machine learning networks can only understand the numerical numbers, not text. Okay, so as a part of the data pre-processing, we use the label encoding to convert this text label into numerical format or value. Example for 0, 1, 2. This step is necessary when your output label are in text format. However, in some of case, if your output data is already numerical, encoding is not required. In here, these are in text format. So we want to encode. If you just think the column is already in the numerical format, encode is not required. So encoding is a key part of the pre-processing to ensure the data is suitable for training neural network model. So when we come to the pre-processing part, so we can do like this. So pre-processing categorical. Categorical data. So in here, you want to form scaling dot pre-processing. Pre-processing import label encoder. Label encoder. In here, in this line, import the label encoder like class from the scalar and pre-processing model. And label encoder is used to convert the say like this categorical label like text into numerical form, which is essentially for the training most machine learning model. So in here we can convert those values. These are text values. So we can convert it to numerical format. Just think the iris setosa convert into 0, and iris versicolor convert into 1, and iris virginica convert into number 2. It's a numerical format. So in here, so let's we try to convert it. So we are getting some variable as encoder equal to label encoder we can get, firstly we got the capital Y, no? So in here we can get simple y1 equals to encoder dot fit underscore transforms to the capital Y. Enter. So in here we got the encoder equal label encoder. So in this is create the instance of the label encoder class. So think of it is creating a tool that can learn and apply the label conversion. So in here I use fit transformation. The fit look like all ununique label to like iris setosa, iris versicolor, and assign the numerical for numbers for each data. In here you use transform. It is convert the label in Y into the corresponding number. The result can be made numerical arrays like 0, 0, 1 or 2 like this. So finally the numbers converted numerical label into new variable as y1. In here these are the capital Y with the text format, and after the transformation the y1 array representing the numerical data format. Okay, in the we can print the array. We can say like type like this, print y1. We are getting the numerical transformation is y1 print y. Yes, it is representing. In here we use iris setosa for the 0, and in here we are 1 for the versicolor, and number 2 is virginica. So it is representing like this. In the y1 array representing the 50 number of data for the numerical representation as digit 0 for the iris setosa, and versicolor or any other keyword, I think versicolor representing the number 1 for the 50 points, and number 2 representing the virginica point 50. Okay, so so in here y1 contain the output, or we can say target value for our neural network. So each value y1 representing the flow of species of the class column. So these were original. So in here we can say like this. These are the original text labels for the iris setosa, virginica or versicolor, but now those are in numerical format. Yeah, we have transformed. So display all 150 values. If you are using full iris dataset, you can see what the labels are looking at after the encoding. After the encoding and transformation, you can see only numerical format of this last column as class. Okay, and you want to apply one head encoding to the numerical label y1. So and the storage will result in y, capital Y. It is then print the first 5 rows of the one head encoding label. So try out this one like this. The variable name is capital Y. So after we can use PD and get dummies. The transform array name is simple y1, and you want to put values, and you can print like this. Print open brackets with the y, capital Y, not print with the and the main array is y, and open the square bracket. We want to represent with the 0 and to 5. Yes, we try out. Yes, it is showing. For the one hot encoding is a technique to use to convert categorical label into the binary format. In here you can see true or false. We can say 0 or 1. So each label we can create new column, and each column corresponding to one possible category. In this case one species of the flower. If a label beyond the categorical to column get the 1 or 0 or true or false. So in here I use pd.get. So pd.get dummies means function of the pandas that we can perform one hot encoding on the input data for a y1 transformation array. So in here also it creates a new column for each class species and assign binary value 0, 1 or true or false to each row depending on the class it belongs to. So in here use dot values. So dot value extracts the underline the numpy array for the pandas data frames, making it ready for use in machine learning methods. So in here use print capital Y with the 0 to 5. This print the first 5 rows of the one hot encoding label in Y. So after this we want to slip the data. Previously I told I want to divide the data set into main two parts. So first one is training data and testing data. For the training data we used to teach the model, and we are using testing data used to evaluate and how well the model is learned. So we can do like this from a scalar. So scalar and dot model selection, and you want to import training test slipped. So we can say like this training. So import training set slipped. So enter, and you want to create the x-train and y-train and x-test and y-test. In here we can do like this. We can use capital X with the train, and we can use x test, and you can use y train and y test. It is, we can equal to like this train test slipped to x to y. You can say x versus y, x to y, and we can get the test size as %2. Test size equal to %2, and we can get random state equal to 0. It's okay. So in here, what I have done? Why slip the data? In the machine learning and neural network, we must evaluate our model on unseen data. So to check how well it is performed, so divide the data into two parts. First one is training set and second one is testing data. So training data we are using for the used to the training the model, and testing set we are using for the test the model performance. So this prevents overfitting. There are model learn the training data to well the perform Boolean data. So in here use training set slip. So function of the scalar to slip the data easily. So x and y are The X is the features, the input data like sepal, petal, and size. So Y is the label, output class after the one hot encode. So test size as %2. So in here get the test size as %2. That is the percentage, 20% of the data goes to the testing and 80% goes to the training. So random state equal to 0 means ensure the slip is in the same every time you run it. So X train and X test is input training and testing set. So Y train and Y test is output training and testing set. So next, so in here we divide the data set into training data set and test data set. In here, after next we want to create our model, neural network model. So we can do like this. Creating the model. Okay. So to create the model is the variable. It is TensorFlow tf.keras.Sequential. Keras.Sequential, and open the brackets and open the square bracket. Okay. In here you want to code for the firstly you want to consider how many hidden layers you want to insert. Okay, so in here first layer tf.keras.layers.dense. We can input 10 comma with the activation. Activation equal to ReLU. Okay. In here we create the first layer and we can do the same for the second layer. tf.keras layers 10 activation for the ReLU, and we can for the output layer tf.keras layers dense equal to 3. Reason for that, we are getting on 3 species and we are using Softmax here. Softmax, and finally you want to get the model. Give me some error, comma. We are creating model tf.keras.Sequential and tf.keras layers dense. Yes. In here you want to put some comma, and now yes, it is running the create the model. So in here if you use tf.keras.Sequential, this is the way to struct layers one after another from input to output in here. So perfect to sample feed forward a neural network. So say like this. So we creating 3 layers, so 2 hidden layers and output layer. We are input layers, we are input data to the input layer, and we are create first hidden layer. This one is the first hidden layer and this one is the second hidden layer. So first hidden layer with the 10 neurons, and ReLU is the activation function. This 10 is what? This is the 10 neurons. And the second hidden layer we are including 10 neurons, and the output layer with the 3 neurons using the Softmax. Okay, So the activation function. What is the activation function? ReLU, we can get some another activation function, ReLU and Softmax. So introduce non-linearity and help the model to learn the complex pattern for the ReLU. So we are using another activation function as Softmax, convert the output into probability, making it is great for multiple classes classification like prediction, one of the three flowers types. No, so in this case the output consists of the three different classes, so it is the multi-class classifications problem. The iris the classes are the iris virginica, iris setosa, and versicolor. So the Softmax function transforms the output of the final layer into the probability of the description. Okay, so in here, after creating the model, you want to compile the neural network model, meaning it is set up the learning process by specifying. So in here, we can do like this. In here, we can compile the model. So put in some compile the model. So in here we want to get the variable as model dot compile and optimizer. So you want to get the optimizer equal to, you want to get in here with the one quadrant RMS ROP. I will describe it. So after, put some comma after the quadrant, and you want to got the loss equal to categorical and you want to create the matrix function. So in here, after the input the comma, and you want to create the matrix equal to with the accuracy. So you want to input the accuracy somewhere, no? In here you want to compile the model compile the optimizer, it is correct. The keyword is missing. Yes, it is correct. So after we created the model and we compiled the model, so optimizer RM equal to RMS prop means optimizer help the model to learn the adjusting the way to reduce the error. So RMS prop root means square propagation, so it is good for small data and work well in the many cases of adapting the learning rate of automatically. So another thing is we get here loss function. So loss function tell the model how wrong its predictions are. So since this is the multi-class classification, so in this problem there are three type of flowers, so we use categorical part. So it is compare the prediction probabilities from Softmax with the actual one head-on coding and label and actual the error, calculate the error. So in here metric accuracy the metrics that shows the how often the model prediction are correct, and also we can say like this, it is a useful understand how well the model is performing and during the training and testing. So after creating and compiling our model, we can train our model. So far we have almost completed our practical. So now it is time to train in our model. In here we can train in our model like this. So training our model, training the model. So in here you want to get the model top. You want to open the bracket with the X-train. So X-train, with the X-train, and you want to get the Y-train as well. Y-train, and you want to get the batch size. We can get like batch size. We can get batch size 10. Okay, let's see, get the 10. It is correct. Let me check. So equal to batch size 10, and we can get small apertures. Apertures equal to 100. Running. It is running. Okay. It is ending with the 100. It is running 56, 50, 68, 70, 85, and it is stopped in the 100. The 100 means we are use 100 apertures. I will describe it. So in here, in this line, train the neural network using our training data. So it teaches the model how to recognize the pattern in the input features X-train and match them to the correct output labels for the Y-train. In here we get the dot fit. In here, this is the function that start the training process for your model. So in here we got the X-train and Y-train. What are the X-train and Y-train? So these are the input and output data used for the training. So the model will try to learn the relationship between them. So in here I got the 10 batch size. This means the model will look at the 10 sample at a time before the update in the weights. This is the mean of the model will look at the 10 sample at a time before the update in weight. So smaller batch size can lead to more stable learning, especially on the small dataset. Because the reason for that I used the 10. In here I used 150. No, so that's the reason I used the 10 batch size. So another thing is I got approach 100. So an approach is one complete pass through an entire training dataset. Here the model will go through the entire training data 100 times to learn. So it is ending with the 100. So we have limited time now. So that's the reason I got 100 efforts. You can got the 1000 or 1000 more. So getting the some couple of minutes or hours. So in here now we want to evaluate the training model using the unseen test data. So it tells how well the model perform the new input and the data hasn't seen during the training. Okay. In here you want to get the accuracy. We can do like this. It's the loss function and accuracy. Accuracy we can equal to the model dot evaluate. Evaluate to the X test and Y test. So we are using capital X test with the capital Y test. So and verbose equal to 0. verbose equal to 0, and you want to get the print of the accuracy. Yeah, so we can get print. We can get the test accuracy. Test accuracy. Test accuracy with the accuracy variable. Accuracy. So after we can get print of the test lost. Test loss with the loss function. Okay, with the loss function, and we can run it. Is test is not defined. Is the wrong? Okay, now we try it. Yeah, it is correct. So thank you. So in here we run the model and we got the test accuracy. The test accuracy is 1%. Okay, test accuracy is 1. The loss is 0.1. So when we describe this, we can say like this. In here we got the model accuracy. These functions are running the model on the test data and returns. So in here loss we can describe like this. How far of the predictions are from the actual values. So accuracy, how many predictions were correct. So loss for the how far of the predictions are from the actual values, and the accuracy, how many predictions were correct. So you give it X test for the input, Y test for the actual label. So verbose equal to 0 means it is run without the print in the progress bar. So why we want to evaluate? So after training the model, we want to check it is generalizing the well of the new data. So another evaluation is did it overfit it, memorize the training data set, and we want to know how the accuracy is for the prediction, and this is the give us for the final score before we use the model in the real world scenario. So another thing is so now the training model is to make the prediction on new unseen data in the X test, and the stories are prediction result in Y predict. So in here we can use capital Y predict. The first array is capital Y now. So Y predict equal to get the variable as model prediction predict with the X test. We can get the capital X test. Sorry. Okay. And we want to get the closest to the Y predict. Okay. And we run. It is show some prediction for the array. These functions run input through a training model. So it is run the predicted probability for the each classes. Okay. And another thing is we want to convert both actual test label that the model's prediction output from the one-hot encoding format back into the class label numerical 0, 1, 2, and the printed them for the comparison. So in here we can do like this actual equal to, we are using NP for the numpy. Next, open the bracket. We can use for the Y test. For the output result is in the Y array Y test for the axis. X is equal to 1, and we want to predict equal to numpy dot. Next, we want to get the y predict. So capital Y pred, it is axis is equal to 1, and we want to print those you can say like this, print on the bracket, and the function is we can f no, so rf no, only f, and you want to put the actual, okay, actual, and it is want to equal with the actual data, actual, and you want to start with the another thing, print with the f, open the double quoted, predicted result, predicted with the predicted. Okay. In the array shows the actual and predicted. The actually they are inputting, they are thinking it is getting some 2, getting some 1, getting some 0, getting some 2. So predicted value is already the same result. That is the reason we are getting the actual equal to the predict. So there are limited number of the data, no, so we can, and we got the accuracy as 1. The loss function is 0.2. That's the reason we are getting all are correct. So the actual, they are saying, they are thinking getting the 2, the predicted as always 2. So why in here, why we use NP ARG MAXC? So the label, the y test and y pred are in one hot encoding form. So why we x is equal to 1, find the index of the highest value of the each row using the original class label. So actually in here we assign the actual equals to y test and equal to 1. So converting the true label for the one hot encoding, class number equal to 0, 1 or 2. So finally we got the predicted, the convert predicted probability to the class label by picking the highest probability. That is the final things we want to get. So in here we got the test accuracy and test loss. These are the for your knowledge we got we want the final answer is this one. So we want to check the what is the final test accuracy and what is the test loss. So in this lab practical we learn what how there are two main methods to create the neural network model. When we are using when we are doing the second lab session, we are using Anaconda. So we want to create the environment in physically, and we want to import libraries, we want to import packages, we want to import layers. In this lab session we use only through a Google Colab. So we don't need to any download, import libraries, layers, packages. So in here summary of this lab session, we import firstly we import the TensorFlow. So and after we import some required libraries for our neural network. So after importing some layers, and we want to import our correct data set for our neural network model. So after we can print our data set as the graphically representation with the 5 columns or any number of columns. So after we want to verify the final output columns, the data are missing or not. So in here we are get the value count. The final labels are ending with the 150 label. So it is divided into 3 main. So iris setosa 50, versicola 50, and virginica is 50. The total number of flowers are 150. So after we plot the graph of the setosa, versicola, and virginica, and these are the evaluations part. We check the input and outputs are correctly insert for the layers, and we got the pre-processing part. So we done the pre-processing and we done the encoding and transformation, because the reason for that, in here the last column in the text format. So the neural networks models and machine learning models cannot understand the text formats. So we want to transform or convert into the numerical part. So that's the reason we are using encode label encoder. So in here we use the flip the data. So percentage 2 mean we want to divide the data set into 2 main part. First one is 0.8 for the training data. We want to get the percentage 2 for the testing data, and we use activation function, ReLU, Softmax, and we train the model using the 100 approaches, and we got the accuracy and the loss functions. So that is the end of the practical session.